Well, hello there. This is Dr. Dell, Craig Hain. My students call me Dr. Dell, and this is interlude number 2 that you've come to in the Teaching Math book, which, of course, you know how to get more information at triadmathinc.com. And I want to talk to you a little bit about what we do here and why and when we do it in the foundation. Now, the whole idea of the foundation course is we teach the students, as you know, all of the math we feel they need to know to do what I call everyday practical problems, and we include topics then from algebra and geometry and trigonometry. And all of this is done in about 40 hours of student time. A slow student that is a slow learner may take them 50 or 60 hours, and a fast student might do it in 30 hours. And in fact, a student that already knows a lot of this material might do it in as little as 20 hours, because what we have, of course, as you know, is we have a set of lessons that are video lessons on the topics that we think they need to know. And we start with the calculator. As you know, we teach them to use the Texas Instruments 30XA calculator to do all of the drudgery math. And we start with a set of lessons on how to use it. And then we have a set of lessons on pre-algebra, which is essentially a review of arithmetic rules, things that they've no doubt learned in their elementary school training. And then we go into algebra and we start out and just teach them the algebra they need to do practical math. Now, this is certainly a long way from a complete algebra course that they would typically get in their freshman year. And that's why we can go through this, or rather the student can go through it relatively quickly, because we just put in the things they're going to need for practical math. And then we do the same thing with geometry. We go down through, and in the very first interlude, we talked about area of triangles, and these are the different things we talk about in geometry. And one of the later interludes, I'm going to talk about Archimedes' tombstone for you. But today we're talking about trigonometry, and in fact, we have now, the last thing we get into is trig. And so they've already gone through the previous material, and that's what this interlude today is about. Of course, there would be exercises in this book as well as then a lesson in the notebook. So the question that we have posed students in the past, even back in geometry, is what happens if you have a triangle and you know two of the angles and you know one side length opposite one of these angles. Of course, if you know two of the angles, you know the third one, and they've learned how to do that because they know that this sum is 180 degrees of all three angles. But in any event, how do you find the other sides? And there just isn't really an easy way if that's all the information you've got given just using geometry. Now, back in geometry, we talked about similar triangles, and when you had two similar triangles, then you could set up ratios to solve unknown lengths or angles. And they learned all about that in geometry, but now there's only one triangle. And so how do you get to solve the unknown side with that? And of course, that's then where trigonometry is indispensable. And if you are a math teacher, then of course you know immediately the answer to that. You use what's called the law of sines to do that. And the law of sines is something that we cover in trig. In fact, it's our next to the very last lesson in trig is law of sines. We're getting very near the end of the course now, and we teach them that. And so that is essentially how that is handled. The way we teach that in the notebook, I will go to the notebook now and just show you something very quickly that we do. And this is something we often like to do when we're teaching a new topic, is we say, okay, let's just use our common sense. Suppose you had a triangle with two angles you knew, 40 and 100, and you knew one of the sides. Say the opposite, the 40 degree. How would you find this side opposite the other? And we guess at it. Well, what would you do? Well, maybe you would just take the ratio of the angles. Well, you try, it doesn't work. Maybe you would construct a triangle and measure carefully and see what it is, and you get an answer then if you did that. Okay, what else might work? Is there something we might? Well, what if you took the sine of both angles? And if you do, bingo, it works. It meets exactly what you measured, and so there you've got it. And I might tell you, we do not prove the law of sines in the foundation course. We don't prove very much in the foundation course. We defer the proofs until we get into Tier 3. Now, in Tier 3, we use Dr. Simmons' book that I've alluded to, and you've read about it already in our teaching math book. And in the Dr. Simmons book, all of these things are covered, including the proofs and everything. This is a much deeper treatment of algebra, geometry, and trig. It's a wonderful book, by the way, as I've mentioned in my book to you. So we highly recommend it to you. And in this book, we would then, in Tier 3, we would prove that the law of sines actually then was always true. It's very easy to prove, by the way, as you very well know if you're a teacher, but we don't do very many proofs at all in the foundation course. We just want to teach them how to use the facts to do the problem. So then they would do the problem, and then we give them a bunch of problems to do. So that is essentially what I wanted to tell you is how we handle it. And in the next interlude, I will show you the last thing that we teach them in trigonometry, which is how to solve a very interesting problem. So we'll talk about that in the next interlude video. It's Dr. Dell or Craig Haynes signing off. I will talk to you later. Bye-bye.